This is a typical 2D momentum question. In this case, we have a mass, m1. It's striking another mass, m2, and the results of the collision mean that m1 gets scattered upwards on an angle of 40 degrees. So we'll write that here. And then m2 will get scattered at some unknown angle in this direction down here. Now the reason why it's got to be in this direction down here is because momentum are vectors. So this here, because m2 is not moving initially, m1 is has all the momentum. So the momentum after the collision must add up to equal this momentum. So I'm anticipating that there'll be a vector going down like this, and this vector plus this vector will equal this vector going in that direction. So that's my prediction here. So the easiest way to go about this, it takes a bit of time often if there's more than two vectors, is to use components. You can use your trig. For instance, you could probably use the cosine law here, but I like to use the component method. So I'm going to first organize my vectors. So we'll start off with m1. What do we know about m1? Well, we know that the mass of m1 is equal to 1 kilogram. We know that its velocity is equal to 5 meters per second, and that's to the right. And we know that the final velocity of m1 is equal to 3 meters per second to the right, 40 degrees up. Now m2, we know that its mass is 2 kilograms, and it has an initial velocity of 0. We don't know anything about its final velocity. That's what we're trying to find here. Okay, so let's look at the x component. So in the x direction, or in the horizontal direction, we have our total momentum is equal to our total momentum. So this is the total momentum before the collision, this is the total momentum after the collision. So we can break up these totals into the momentum of m1 plus the momentum of m2, and that's equal to the post-collision momentum of both. And this is the x direction, so let's put little subscripts here. And this is 0 because m2 doesn't have any initial velocity. So what we're looking at is m1 v1. So m1 is 1, v1x is 5 because it's just going to the right, and then that's equal to m1 again, which is 1. Now here we have to break v1x into its components. So we know we're looking at this component right here. So that is adjacent to this angle. So we're looking at, that'll be 3 cos 40. And then we add that to the mass of the m2, which is 2, m2. And then we don't know what the x component of that momentum is, so we go v2x prime. So if I take 1 times 5 is 5, and then I bring this part to the left, so that's minus 3 cos 40. And then I'll have that 2 left over, which I'll divide And this works out to be 1.35 meters per second to the right. Now, in the y direction, so let's use the color red for the y direction. So the y direction, it's the same idea. We have the total momentum in the y direction before the collision has to equal the total momentum in the y direction after the collision. Well, the total momentum in the y direction is 0 because neither object were moving up and down in the y direction initially. So that's the value 0. The second part is equal to m1 v1 prime y plus m2 v2 y prime. So we know that m1 is 1. We know that v1y, if we look at this diagram here, this is opposite to this angle. So the component of this velocity would be 3 sine 40 plus 2 v2y. And if we solve this algebraically, we get negative 0.96 meters per second up. So if we just look at these directions, we can see that initially I had sketched a velocity vector going down and to the right. Well, we can see that's happening here because our vector, our v2 prime vector, the post-collision vector, is going to the right and down because that's a negative up. So we've done the tricky part in terms of the momentum ideas. Now all we have to do is combine the two components and give us an overall resultant. And the way we do that is we use Pythagorean theorem. So let's just combine our two answers. So v2 is equal to v2x squared plus v2y prime, so that's prime, squared. And the numbers that we're using the algebra on are these two numbers. And that works out to be 1.66. And then when we want our angle, I like to use the inverse tan of the y value. And in this case, the y value was 0.96. And I also like to take off the sign. And the reason why I can do that is because I already know the direction, so I don't need to include it here. So this works out to be 35 degrees. So our final answer is the velocity of mass 2 is 1.66 meters per second to the right, 35 degrees down. And the reason why I knew that was to the right first is because if we sketch this out and we look at the triangle that we made, we were looking for this angle. And the reason why I know that is because tan is equal to opposite over adjacent. And the opposite side here is the y value. The adjacent side here is the x value. So it's y over x. If we had drawn the other triangle, so if we had drawn a triangle that looked like this, which is perfectly okay, we would be finding this angle here. And in this case, our opposite angle is our x value. So that means that we'd have to take the inverse tan of the reciprocal of this number, of this value here. And then that would give us the angle 55, because 90 minus 35 is 55.